Hello, Dr. Manigold. My name is Nikhil Mahalanobis, and this is my final project presentation, Linux, the secure OS of the future. So, to give an introduction, like I said, my name is Nikhil Mahalanobis. I am a senior computer science student at UCF, and when I graduate, I hope to become a game developer and join the game industry. My topic, like I said, is Linux, the secure OS of the future, and I'm going to be giving an overview on Linux as an OS as a whole and how Linux will be impactful on the commercial use of operating systems in the future. And so I'll go through the history, problems, solutions, and some practical uses. So I think it's good to have a brief history of Linux to understand the motivations, and it all starts in the 60s with Unix. So Unix was developed out of a project called Multics, which was a project at Bell Laboratories, which later would be known as AT&T, and they basically wanted to make a multi-user OS with certain features like single-level storage, dynamic linking, and a hierarchical file system. Unfortunately, though, this Multics project stops getting funded in about 1969. And so the researchers at the core, which are most famously Thompson and Ritchie, keep working on it. And they end up developing Unix totally in C in 1973, which is sort of the first portable version of Unix. Um, Academic wise, research continues, most famously done by the research group at Berkeley, which they ended up producing the Berkeley software distribution, the BSD, in 1977. And two major softwares are going to come out of the BSD. Next Step, which ends up being the basis for Mac OS in the future, and Minix, which would sort of end up being the basis for Linux in the future. However, at this point, Unix is still proprietary, right? So like source code is available, but editing and redistributing source code is still restricted. So not totally like, open source. And this is going to, enter maybe the two most accredited developers in this process, Richard Stallman and Linus Torvalds. So Stallman worked at MIT's Artificial Intelligence Laboratory, and that's where he started work on the GNU project. He later ended up launching the Free Software Foundation, the FSF, in 1985, and distributing the GNU for free. And so a couple of years later, Linus Torvalds, he is frustrated with all these licensing and restriction issues with Minix. So in 1991, he announces he's developing his own OS, very similar to Minix, but it runs using the GNU-C compiler made by Stallman. And thus, this is the first modern implementation of like the modern Linux kernel. And thus, we say Linux was born. And so the biggest takeaway here is understanding the motivation that, you know, they really wanted Linux to be non-proprietary, free, open source, and that's very important. And so to show the diversity of the open sourceness, there's so many different flavors of Linux, right? Debian is the longest standing one, over like about I think 50,000 packages. It's been around the longest. Ubuntu is the most popular commercial one, so that's the one you really use when getting people into Linux who have never used Linux before. And then there's a bunch of others as well, like Red Hat, which has Fedora. There's CentOS. There's Arch Linux, and so many more. Um, Now, the problems in a world where the internet and computers is at the center of everything and people use them in their day-to-day lives, cybersecurity is as important as it's ever been. And if you use a computer in your everyday life, especially for work, you should know how to secure your computer. You should be educated in cybersecurity. And in my opinion, if you are educated in cybersecurity practices, Linux does security the best because it gives the user total control. However, the problem here is that most consumers in the world don't use Linux or have even heard of it before. So, this is some statistics pulled from Wikipedia. Out of all of the desktops and laptop machines in the world, roughly estimated 77 to 87% of those machines are running Windows, and about 9 to 13% are running Mac, and only 2% are running Linux. So that's a huge disparity, especially for Windows, right? And this presents a huge problem for Microsoft and Apple because they have the biggest targets on their back, right? Of course, if 80% of the world is running Windows, then as a hacker, of course, I'm probably going to target Windows more than Linux, right? And so what this means is that, well, since it's proprietary software, the development teams at Apple and Microsoft are the only people securing and developing and patching for their OSs. There's only one group doing it. And this kind of encourages the consumer to be lazy, right? It's that idea of like, okay, let Apple and Microsoft handle all the work and you don't worry about it, which it might be good for the user experience, but in the long term, I believe that's a huge threat to confidentiality and integrity if you stay ignorant on cybersecurity practices. And so for the solutions, I can't go through all of the security applications that Linux provides. Like the professor said earlier in the semester, you could take a whole class and not cover everything. I just wanted to go over some of the most important things and then a few specific examples. So, like I've been preaching this whole presentation, the biggest advantage to Linux is the open source factor because this gives the power completely to the user, which is why I said if you know what you're doing, handles security the best. There's no proprietary company or entity or component, and this allows you to do many things like auditing source code yourself. You can literally, depending on the software you're editing, you can patch it yourself if you have access to the source code, or you can directly submit an issue via GitHub or whatever repository the source code is published on, right? Like directly submitting a ticket. Um, if auditing source code is an issue with certain proprietary softwares, then you can install sandboxes in containers to wrap this proprietary software to secure it better, right? And this is where I'm going to segue and show you guys a specific wrapper called Bubble Wrap. This is Bubble Wrap for Arch Linux. So this is the Arch Linux documentation site. And it says Bubble Wrap is a lightweight sandbox application uh, that is used to wrap certain proprietary software. And that's the thing about Linux. It's very well documented and it's very easy to follow. I mentioned the package manager, and like I said, you know, the Pacman package manager. So this is a user-driven package manager, right? Very easy to install software. If you come to the actual package bubble wrap, though, like you can see the details, you can actually get the source files and you can add bugs. So, like I said, direct access to the GitHub source files, and you can submit directly any bugs that you come across on. And they even certain documentation even has tutorials for installing certain proprietary software like Firefox, right? Very popular browser. It gives a whole run through on configuration files, making sure it's wrapped properly. Skype, right? So very, very powerful for the user. Like I said, security is user driven rather than corporate driven. The Pacman pack manager, whatever package manager you're using, is community driven. That's how you update your OS. And I wanted to go over for like just a few specific examples for securing Linux servers. So one of them is fail to ban. This is a package that scans log files, Apache log files, and it bans IPs based on very malicious signs like too many password failures, trying to seek exploits, etc. And like I said, it makes it you can either download it or there's a README here where you can straight up install it from the command line, installing the packages, configuring the packages, or starting the fail to ban client and configuring the packages, or you can come down to your and find your distribution and find out how to install it with whatever package manager is running on your distribution. Uh, but it's not just official OS documentation, right? Like I said, because it's open source, any third-party website can publish software. So this is one for on TechMint, which is a Linux blog. They publish how to secure network services using TCP wrappers in Linux, and like I said, all done to the command line. Very simple instructions to follow. And there's one for securing FTP servers using SSL and TLS on Ubuntu, right? So again, third-party development, power is in the user's hand, very well documented, very easy, straightforward instructions, and it's user secured, right? And so these are just a few examples. Like I said, I can't, there's thousands of security implementations out there. These are just examples of a few of them. And so, I just wanted to go through some real world applications. Raspberry Pis can be programmed with Linux, right? A bunch of popular companies that use Linux every single day. Google, right? Not only do they run Linux on their servers, they literally have their own OS. They used to have one called Ubuntu OS based on Ubuntu. They changed it modernly, so now more recently it's now called G Linux, which is a distribution variant on Debian. Uh, Facebook and Amazon, of course, notably that a lot of their servers run on Linux distribution, especially Amazon. Just about everything they do runs off of a Linux server, especially AWS servers. Some less commonly known ones, maybe DreamWorks Animation. They've been using Linux since 2001. And according to them, they have about 1,000 desktops and 3,000 servers running Linux over at DreamWorks. And then the one that surprised me the most, Burlington Coat Factory, has been running Red Hat since 1999, which was crazy to me. I didn't think that they would run or were interested in Linux. NASA uses Debian in the ISP. They replaced a bunch of laptops that were running Windows and switched over to Debian 6 because they wanted that power to be able to patch whenever they could, that open source. And the United States Department of Defense, they use lightweight portable security distributions that are bootable via USB drive. So very, very portable, efficient. And so, to synthesize and bring it back, the most important factor of Linux is the open source. Like I said, if you understand what you are doing, if you are educated in cybersecurity practices, open source software is the best because it gives the user the power. First of all, free software is awesome. And the ability to write your own code, patch whenever, and make it community driven is, in my opinion, very, very good for security, implementations. However, it's not good for, user friendly UI or for the average user, and that kind of goes back to being able to educate the user on cybersecurity. Um, Linux is very low profile compared to Windows and Mac, right? The two most popular OSs in the world. Linux is nowhere near as used in the day-to-day basis. And this is a pro and a con. So a pro is that makes Linux less of a target in general, especially compared to Windows. But the con is that with most people using Windows and Mac, security for the future looks a little scary because people are getting lazy with security, right? You'd figure the more complex technology gets, the better the security gets, but it's sort of the opposite. It's more of like, well, Microsoft and Apple are just saying, well, let us do it for you, and then the average user doesn't care, which I think is a huge problem. So, you know, the potential solution here is to really hope that the general public educates better on cybersecurity, and once they truly understand the potential of a computer or a server, migrate over to Linux and have the power truly in your hand. And um, that's sort of where I believe Linux is the secure OS of the future because it truly doesn't rely on one entity or company doing all the work. It puts the power in the community, the developers' hands. And so these are all my references, and this marks the end of my presentation.